In the name of God, the most merciful, may the peace be upon you and God's mercy and blessings. We will solve Brecht's problem 735, which is about developing load function W of x, shear function B of x, and moment function M of x by using the discontinuity function. The same problem is 759 in the third edition. The Brecht's problem is included in Professor Timothy Philpot's book, An Integrated Learning System, Mechanics of Materials. We have a given cantilever beam with a span of 6 meters acted upon by one downward concentrated load of 5 kilonewton at point A and one concentrated moment of 20 kilonewton meter acting clockwise. It is required in part A to use a discontinuity function to write the expression for load W of x in part A and to include the beam reaction in the expression. In part B, it is required to integrate W of x twice to determine the Vx and M of x. In part C, it is needed to use V of x and M of x to plot shear force and bending moment diagrams. First, we draw the free body diagram. This is the free body diagram in which we remove the supports and replace it by points. And this is the beam. At the left part, there is 5 kilonewton acting downwards, and this is the clockwise moment acting after 3 meters from the left end. And at the support, we include two reactions C of x, C and of y, and a moment about C called M of C. From sigma x equals 0, since there is no acting horizontal loads, we'll find that C of x equal to 0, while from the summation of y equal to 0, we have only one vertical load, so Cy equals 5 kilonewton. For the positive direction, from left to right and from the bottom to top, these are the positive direction for horizontal and vertical loads, while for the acting moment, we have anti-clockwise direction as positive. We take the sum of moments of all forces about the right support C, then we consider the anti-clockwise direction as positive. We have 5 multiplied by its arm, which is 6 meters, minus 20, because it is in the clockwise direction. And the MC, we assume it is in the clockwise direction, so it will be considered as minus MC. We equate to 0. So we have 30 minus 20 equals MC equals 10 kilonewton meter. Now we will start to write the expression for W of x in the next slide. W of x equals minus 5 since it is going downwards, multiplied by Macaulay's function expression, x minus 0 raised to the power of minus 1, because we are talking about load intensity. And then after 3 meters, we have clockwise direction. We consider plus 20 multiplied by x minus 3 raised to the power of minus 2. And at x equal to 6, we have 5 kilonewton, so we write plus 5 multiplied x minus 6 raised to the power of minus 1, and followed by the moment in the clockwise direction, plus 10 multiplied x minus 6 raised to the power of minus 2. For the two items that represents the reactions, vertical reaction and rotation, we don't consider in the calculation, but since he wants to include in the expression the beam's reaction, we are going to integrate one and second time, but in the calculation, because they will start to work after x more than 6 meters, and we have the span only 6 meters. We integrate one time, so the v of x equals minus 5, x minus 0. We have minus 1 plus 1, it will become power of 0, plus 20, x minus 3 raised to the power of minus 2 plus 1, it will be minus 1. Again, plus 5 multiplied x minus 6 raised to the power of minus 1 plus 1 equals 0. And the last item is plus 10 multiplied by x minus 6 raised to the power of minus 2 plus 1, it will become minus 1. Integrate one more time, so we have m of x equal minus 5 multiplied by x minus 0 raised to the power of 1, plus 20 multiplied by x minus 3 raised to the power of minus 1 plus 1, it will become 0. We don't divide on 0, because this is not an ordinary function for in the integration. Plus 5 multiplied by x minus 6 raised to the power of 1, plus 10 multiplied by x minus 6 raised to the power of 0. Then we have reached to parts A and B. We have achieved the requirements of using the discontinuity function to write the expression, and we have integrated wx twice to get the expression of v of x and m of x. In the next slide, we have included the v of x. We will write it as vx equal minus 5 multiplied by x minus 0 to the power of 0, plus 20 x minus 3 raised to the power of minus 1, plus 5x minus 6 raised to the power of 0, plus 10x minus 6 raised to the minus 1. For the first item, it will be valid all over the length, while for the moment expression for shear, it has no effect on the shear calculation. It will be disregarded, plus the third and fourth item will be disregarded because they will act only when x is bigger than 6 meters. We started with v at x equal to 0. It will be equal to minus 5 multiplied by, we consider 0 plus or more than 0 by a small value. So we have positive value raised to the power of 0, it will become 1. And this is no effect here. So we add 0. Now we have minus 5 kilonewton. For v, the shear value at x equal to 2 equals minus 5. Again, 2 minus 0 raised to the power of 0 is 1. So we have minus 5 by 1 plus 0 equal minus 5 kilonewton. We continue to estimate the shear value at x equal to 3. We have minus 5 multiplied by 1, 3 minus 0. And here we disregarded the expression. So we have 0 minus 5. For v at x equal to 5, we have minus 5 multiplied by 5 minus 0 raised to the power of 0 equals 1. And this if no effect, so we write plus 0. We have minus 5 kilonewton. At the last point at x equal to 6, we have vx equal to 6 minus 5 by 1 minus 0 equals 5 kilonewton. We have come to the end of the estimation of the shear values from x equal to 0 to x equal to 6 meters. We have moment acting at x equal to 3. So we are expecting to have a drop in the moment. Now, for the expression of m of x, we have m of x equal to minus 5 multiplied by x minus 0 raised to the power of 1. This is a moment due to the concentrated load, plus 20 multiplied by x minus 3 raised to the power of 0. There is, here is a moment, and multiplied by value raised to the power of 0, it will lead to 1. So there is consistent units. And the third expression, 5 multiplied by x minus 6 raised to the power of 1, plus 10 multiplied by x minus 6 raised to the power, this is actually raised to the power of 0. But the third and fourth item will be disregarded. At the moment value at x equal to 0 equals 0, minus 5 by 0 equal to 0. M at x equal to 2 equals minus 5 multiplied by 2 minus 0 raised to the power of 1. It will become 2 minus 5 by 2 plus 0 equals minus 10 kilonewton meter. At M at x equal to 3 equals minus 5 multiplied by 3 minus 0 minus 15 plus 0. Here we consider the 3 exactly. So we have minus 15. This is the first drop. The first value is minus 15 kilonewton meter. If we consider that we have x equals 3 plus or smaller value more than 3, so we have minus 5 multiplied by 3 raised to the power of 1 plus 20. X minus 3, we consider this as a positive value raised to the power of 0. It will become 1. So we will add the 20 here. Minus 15 plus 20, we have plus 5 kilonewton meter. So there is a drop minus 15 to plus 5. The total drop value is 20, which is the value of the moment acting. M at x equal to 4 equals minus 5 multiplied by 4 plus 20 multiplied by 4 minus 3 raised to the power of 0, which will be equal to 20. 20 minus 20 plus 20 equals 0. For M of x equal to 5 equals minus 5 multiplied by 5 minus 0 minus 25 plus 25 minus 3 raised to the power of 0 is 2 raised to the power of 0, 1 plus 20. So minus 25 plus 20 equals minus 5. Finally, M at x equal to 6 equals minus 5 by 6 plus 20 multiplied by 6 minus 3 to the power of 0 is plus 20. So minus 30 plus 20 is minus 10 kilonewton meter. In the next slide, and from the information we have after the calculations, in the shear, for the shear diagram, shear force diagram, we have negative shear starting from x equal to 0 to x equal to 6 of the value of minus 5 kilonewton. So, and this is the datum line. We draw minus 5. We draw 5 kilonewton below the datum line. When we come to the bending moment diagram, the positive value is acting upward, and this is the datum line x value in meters. We have M at x equal to 0, we have 0, and at x equal to 3, we have minus 15, and a step coming up plus 15, plus 5 kilonewton meter. And then we have 0 moment at x equal to 4, while we have minus 10 kilonewton at x equal to 6. We have slope by connecting plus 5 to plus 10, we have a slope of 5 kilonewton per meter. Since we have 3 meters, so we have a drop 15 going down from plus 5 to minus 10 kilonewton meter. In this next slide, I have included an Excel sheet of 3 columns. The first column A represents the distance x in meter starting from 0 to 6. And since there is a drop in x equal to 3, I have included 2 rows, 3 and 3. The second column is expressing the shear value V of x in kilonewton, and the third column expresses the moment in kilonewton meter. This is the expression for the shear V of x equals minus 5 multiplied by x minus 0 raised to the power of 0 plus 20 x minus 3 raised to the power of minus 1 plus 5 multiplied by x minus 6 raised to the power of 0 plus 10 x minus 6 raised to the power of minus 1. We disregard this second term because there is no effect in the shear due to the moment, concentrated moment. And for the third and fourth element, due to that we are dealing only from 0 to 6, and these steps will appear after x more than 6. We use this Excel function if and. So we'll discuss what is the shear value in view of x for A17. A17 would represent the x. So if and, comma, we have A17 bigger than 0 and A17 less than or equal 3. We put the equal sign for the first 3 meters, comma -5. This is as if it is -5 multiplied by 1. Again, the second condition for the values from bigger than 3 and less than 6. So we have here if and A17 bigger than 3, comma A17 less than or equal 6. We have the shear value only -5 because we disregard this one. If we come to the second expression for the other 3, we put another 3 to create step function in the Excel. So we have if and A18 bigger than or equal to 0, and another one A18 less than 3. We don't put equal sign here, comma -5 for the second expression, which represents the value of the shear bigger than 3, less than 6. We put A18 equals and bigger than 3, comma A18 less than or equal 6. We have only one shear value, -5. This is the expression for the shear for the second 3. We find there is no change in the shear as we have earlier estimated. We have -5 and -5, but later in the moment, this is the drop in shear. If we use the Excel to draw based on the table we have created, we'll find that exactly it draws -5 kilonewton meter with a relation between x and the value of the shear. We have -5 from x equal to 0 to x equal to 6. Then we are going to move to the next slide to check the expression for moment. In the next slide, we have the expression of moment. M of x equal -5 multiplied by x minus 0 raised to the power of 1. This is a moment due to the concentrated load, plus 20x minus 3 raised to the power of 0. We will not disregard because this is a moment. And the third, fourth term we are going to disregard since they are acting for the moment values for x bigger than 6 meters. The expression here for the upper 3, we have if and for C17, if and A17 equals bigger than or 0, comma A17 less than or equal 3, equal to -5 multiplied by A17. This is replacing the x in this term. The A17 is replacing the x, comma. And then let us check if and A17 bigger than 3, A17 less than or equal 6. -5 by A17 plus 20 by A17 minus plus 20 multiplied in 1, because this is raised to the power of 0. So we are going to write 1, comma 0. And if these values does not satisfy the requirement, the cell value will be 0. We have two conditions, then we have two brackets. While for the expression for the C18, the moment value of the other 3 to include the drop, if and A18 equals bigger than or 0, and comma A18 less than 3, we don't put equal here, comma minus 5 by A18. This is the first term, minus 5 by A18. Comma if and A18 equals big or bigger than 3, comma A18 less than or bigger than 6, we have two terms, minus 5 by A18 plus 20 multiplied by 1, because this is raised to the power of 0. We use this expression starting from here to here, so we have the moment 0, minus 5, minus 10, minus 15, and this expression from 3 going down to 6, we have 5 and 0, minus 15, minus 10. This is the last slide, and based on the information from the previous table, we have drawn by using the Excel sheet. This is a draft of the moment values for moment values from 0 to 6. We have again here 0 at x equal to 0, and we have minus 15 at 3, and plus 5 at 3 also, but we have, since we have included 2 points 3 and 3, and we have used the expression to create the values minus 5 plus 5, then we have the step very clear, and we have 0 at x equal to 4, and we have minus 10 at x equal to 6. Thank you. God bless you all, and goodbye.